Hey everyone, thanks for the massive response to my Apollo 8 versus Artemis II trajectory comparison. Many of you loved the rotating Earth-Moon frame visuals, but others raised some sharp points. Why no lunar orbit on Artemis II? Is it just fuel shortage from boil-off? Why is Orion less capable than the Apollo Command and Service Module? SLS Block seems weaker than Saturn V. These are all great questions, and let's just hit one by one. Let's take them head on with facts from NASA docs, trajectory analysis, and mission planning. Now, this isn't defending or criticizing. It's explaining the engineering trade-offs. First, the big one was Artemis II skips lunar orbit because of fuel limits, not just safety. And the answer is partially true. But safety is the root cause. Unlike Apollo 8, which went directly after Apollo 7's thorough Earth Orbit Command and Service Module checkout, Artemis II has no prior deep space crew test flight. So NASA built in 24 hours in a high Earth orbit for full checkout of Orion's life support, radiation shielding, etc., and even proximity ops with the spent ICPS as a docking proxy. Now, this loiter means cryogenic liquid hydrogen and liquid oxygen in the ICPS boils off significantly. Hydrogen is especially prone over hours in space without active cooling. Result? The ICPS can't do the full TI load burn like Artemis I or Saturn S4B. Instead, it's a multi-trans lunar injection. ICPS does most of the orbit raising and initial push, providing the bulk of delta V to get to this high apogee orbit. Then, Orion Service Module finishes the TL. This leaves the ESM with limited reserves, no real margin for dropping into lunar orbit and then escaping again. Safety checkouts override max performance. Better to test close to home than risk deep space with unproven systems. Let's go back to the next question. Now, comparing hardware, Saturn V's S4B upper stage was massive and powerful. We can see it here. It could send 45 tons to TLI after the parking orbits with a high-thrust J2 engine and generous margins. On the other hand, SLS's Block 1 ICPS, which is really a modified Delta IV upper stage with a single RL-10 engine, delivers 27 to perhaps 30 tons to TLI under these conditions, less capable due to its size and design priorities. Apollo's service module had somewhere between 2,500 and 2,800 meters per second of Delta V. This is significant amount of redundancy. What about the Orion European Service Module? Perhaps in the region of 1,200 to 1,500 meters per second. So this is more optimized for flybys, NRHO docking in later missions, and reliance on future landers and gateway. What's the difference? 1960s engineering had limited simulations. Von Braun insisted on huge safety margins. Today, with precise modeling, better materials, and risk-informed design, Artemis trims excesses. Block 1 is just enough for flyby. Block 1B's exploration upper stage fixes this for orbital missions and payload. Again, this is nothing to take away from the amazing engineering and what they did in the 1960s, truly decades ahead of its time.